Hey guys, it's Brad from Roboflow, and this is the first in a series of video tutorials on hacking your Google Nest camera to run custom machine learning models. So the premise of today's video is that my wife and I recently moved downtown and we're thinking about getting rid of one of our two cars. So I'm going to hack my garage camera to keep track of how often both cars are in use at the same time so that we can make an informed decision. We're going to go through everything from setup to training a model to putting it all together and all of the code in between. But let's fast forward right now to the end to see the final result. All right, so let's jump right in and see how we built this. So the first thing you're going to need to do is go to our GitHub repo that we made for this tutorial. I left the link in the description below, along with a bunch of other assets that we're going to need for this tutorial. The first thing you're going to need to do is clone the GitHub repo to your local machine. Then you'll cd into that directory and do npm install to install all of the dependencies. If that throws any errors, it probably means you don't have Node.js installed, and so you'll have to Google how to do that in your local environment. So once we open up the project that we downloaded, I'll get you acquainted with the directory structure. So we've got an assets folder, which is where we're going to download the images from the Nest camera. We've got a collect folder, which is for part 2. So don't forget to subscribe and ding the bell so that you learn when part 2 of this tutorial comes out, where we're going to be improving the model. And then we've got this infer directory. So this is where all of the code lives for that demo that we just saw. This is where we'll be spending most of our time today, is diving through this code and showing you how it works. And then the other two important files down here are the Nest config and the Roboflow config. So these files are how we're going to pass in the authentication to be able to read the image from our camera and be able to get predictions from our trained machine learning model. So getting the Nest config is actually the hardest part of this whole thing. Luckily, though, there is a pretty in-depth, step-by-step tutorial that I followed that you should be able to follow as well. So to be able to access that and get these values that are going to be able to trick your Nest camera into thinking that our server that we're creating is the iOS Nest app. We're going to go over here in my repo. If you scroll down, there's this link here to this other repo. And this is the unofficial Nest Node.js API that we're going to use. Unfortunately, Google disabled and discontinued the official API, so we're going to have to hack in with an unofficial API that's pretending to be the iOS app. So if you scroll down, you'll find this whole section about obtaining your Nest security credentials. The gist of it is you're going to install a proxy on your local machine, and then you're going to set up your phone to go through your local machine every time it's making a request to the internet. And then you're going to be able to look at the request that it's making and pull the IDs and the access tokens out of there. So this tutorial walks through using Charles Proxy, which is a Mac application, and the iOS app. It's pretty simple. You just download it from the web, and then you'll install the security certificate, which lets it decrypt the encrypted traffic that's going back and forth between your phone and the Google Nest API. And then it'll walk you through how to enable it on your phone, how to set it up to go through your computer, and then what you're looking for here to put in the ID of the camera and the credentials for pretending that you are the app. So once you grab those, you'll put those in this nest config.json file. The only trick is, or the only difference is that they just have this single Nest ID in their config. I split that out because in the future I want to be able to access multiple cameras. So I've got my garage camera, I've also got my doorbell, and I've got one over my shoulder here. And I thought it would be useful in the future to be able to build other projects if I had those split out. So for this tutorial though, our server.js is just going to pull the first entry from this list. So if you put your camera ID here, and then the other three values that you find in here, you should be set to go. So the second file is the Roboflow config. So we need our API key, which we can pull from within Roboflow. So if you go up at the top of the page after you log in, there's this account section, and then go to Roboflow API, click show here, and that'll give you the value that you will copy here. And then the model ID, I'll show you in a second how to get that. And then both of these, you'll need to, once you fill in your values, save them without the .sample in the file name. So for obvious reasons, since I don't want you to be able to watch my Nest cameras, I don't want to show you my official configuration file. But these config.json without the .sample is what our server.js is going to read here in a minute. Okay, so once we have that configuration set up, and I'll show you how to get this model ID in a second. Oh, also upload dataset. That's for part 2 of this tutorial. So that'll be coming in a little bit. It's just this first one that you need and the third one. Okay, so I'm going to go back into Roboflow and kind of show you what we've got here. So I actually wrote a whole tutorial about how I generated this car dataset from 2 open source datasets. So I pulled about 17,000 images from the Coco dataset and the Open Images dataset that were all labeled with cars. I pulled them into Roboflow and then trained a model that's able to recognize cars. So I'll show you a little bit of that. So if you look in here, these are the images that I pulled that were already labeled. If we click into here, we can see kind of what's labeled. And you'll probably notice these are not pictures of cars in garages. And so that's why earlier our model didn't do particularly well. It found the car a little bit, but we're going to do part 2 of this tutorial to improve the model. So a lot of these, like I probably, if I was making this data set, probably would not have labeled this car up here. There's no way that you can expect your model to find that. That's probably just adding a bunch of noise. But regardless, it did good enough for our first pass. So those were the labeled images. If we come over here, we can see that Roboflow train here, I clicked train and I got results. And we can actually try our model in a bunch of different ways. So the curl command is what we're going to end up mimicking, or you can go to the docs and we actually have a code snippet for Node.js and Python. That is what I copy and pasted into my project, which we'll see in a second. But to give you an example, if I click this direct URL, I can see here like just how it's predicting on an image it's never seen before. And in fact, this was an image that I just pulled from Google Images. I searched for red light camera, and actually I couldn't find it when I went to record the video, so I had to dive in and find the exact image. But this is what I pulled up here, and then this was the result from the model. But you could put any image here. So this is where we need to go to get that model ID. So if you look in the URL, after I click either direct URL or curl command, it'll give me this URL. The first part of this URL here where it says L-car detector --3, that's my model ID that I need for Roboflow. And then access token is what we grabbed earlier from the settings. When you look at this, I'll have blurred this out since I don't want to give you access to my Roboflow account. So keep that secret. That is essentially a password to your Roboflow account. Okay, so once you copy paste those values into these configuration files, you're ready to essentially start pulling images and doing inference. So the structure of this infer directory is that we have a server.js file, and this is an express server, which is basically a very simple web server in Node.js. And I'll walk you through the code of how this works. So first, we load in all of our dependencies. Again, really standard stuff, except for that unofficial Nest Cam API that I showed you the repo for earlier. We'll pull in our config files. So this reads the Roboflow config.json and the Nest config.json, and then parses those and stores them into a Roboflow config and a Nest config constant that we'll access later. Then we pull out the camera ID and the camera name, which again here we just pulled the values and the keys from that file and pulled the first one from it. And then we're going to set up the unofficial Nest API. So this is analogous to what I actually showed you, where we in that repo, we're taking this camera ID and putting it in the nest ID, in their nest ID, and then we're grabbing our Google credentials. I'll jump over this part since this is going to be the meat of what we talk about. But if I go to the bottom, you can see the final bit of setup. So we're going to clear out any assets that are left over from the last run of the app with a tool called rimraf, which is just rm-rf. Essentially, it's gonna remove all of the images from that folder. And then we're going to call init on our nest instance. That's going to connect and authorize us to the API. Then we'll call subscribe, which is going to call our callback function every time a snapshot is received. So this is how we're, quote, streaming from our camera, is that the unofficial API is listening for these requests, and it's calling something every time the image comes back. So it actually saves this image inside this assets folder, which I'll show you in action in a second here. So since we don't want to save permanently every single image that comes through on our disk, if we had an image before, we're going to remove that one before we update our reference to the new one. And if not, we'll just save the reference the first time. So the first time the code comes through here, it'll skip this first part, and it'll just set current image equals image path. And then the second time, it'll delete the old image and then set current image equals image path. And then once this setup is all done, we tell our Express app to listen. I have mine listening up here on port 5000. So this is app is just app equals Express and then app.listen. Okay, so the middle part of this code is the, I guess, interesting bits. So we tell it that we want to use all of the static files inside of public. So that's our index.html, our main.css, and our main.js file. So if you hit a URL and it happens to be a file that matches one of those names, it'll return that back. And then we've got two functions. We've got get current image, which is going to grab the image that we're recording from that snapshot listener. And we've got infer, which is going to pass things to the Roboflow API. It's going to pass that image over, get predictions back, and then return a promise that resolves with the image data that comes back from Roboflow with the visualization of the prediction from our model. So we'll come back to this in a second, but I'll scroll down and show you the other two parts of the app. So we've got two routes that are going to be in the Express app that are dynamic routes. Everything else is those static ones that just pull the index.html and main.whatever files. So the first one is just at the root. We want to send our index.html as well, just so that we can go to localhost 5000 and get the index file. And then we've got /image. So I guess the best way to show this is I'm going to open up a terminal and start the server. So I'll run this server.js file. Oops. Okay, so here I'm in this same folder, in this infer folder. And so I'm going to run node server.js, and this is going to run this current file that we have open, and it's not going to print anything out. It's just going to get to the bottom. It's going to listen on port 5000. So if I go back to my web browser here and I just go to localhost 5000, I'm going to see that it's going to grab the current image from my camera. And so to see how this works, we're going to go through the JavaScript that's actually pulling this, but it's not magic. If I go to /image, I'm going to see that it's going to download an image here, which is that exact image. And so this image file, this image route at localhost 5000 /image, is this route here. And so every time you hit /image, it's going to get the current image, which we had up here, that uses the cached version that we got from the snapshot from the nest subscribe. So current image was here. The reason we have a function for it is if you hit it before that current image was set for the first time, so like immediately when the server boots up, we want to wait for that, and so we'll recursively call itself until there's something there to return, and then we'll return that back. So it gets the current image, and then it passes that image path to infer. And so you can see over here, now that the server is running, this is getting saved every time a new image comes in. It's saving the raw feed from my camera. And so the server.js file is essentially just passing this local path to our infer function, which passes it to Roboflow, which gets the predictions, and then it returns that prediction image and then sends that to the client. So this prediction image here is what we're seeing right here. This is coming back from Roboflow, which was the /image file. So Roboflow ingests in the image that we pass it, and then I'll show you in a second, there's an option where it will return back that image with the bounding box on top of it, of the prediction from the model. Okay, so the only other function inside of the server that we haven't looked at is this infer function. And as I mentioned, that's going to take in the image path and then pass it to Roboflow. So the way that it does that is it's going to take the image path, which again is this asset/snap timestamp. It's going to read that file with the encoding of base64. So now we have a file, a base64 file called image, which maybe, I don't know if you guys know what base64 is, but it's like a ASCII encoding, essentially, a text encoding of the binary. So I can actually log that out, and then if I pull back up the server and reboot it, every time infer is called now, let's see if I can get this on the screen at the same time. So since I rebooted this server, it's now getting a broken image. But let's get that on the screen at the same time. So if I reload this page, every time this image is coming through, we're now seeing this text representation of the image, and that's what gets passed to Roboflow. So let me kill that server again. Come back over here and remove that guy. I'll start the server back up, and we should be back up and running here in a second. There we go. Okay, so the server is streaming again and pulling stuff in. So every time we call infer, it'll read the local image, and then it'll use this library called Axios to pass that to Roboflow. And if you look at the Roboflow docs at docs.roboflow.com, you can go to the inference API and see this exact code translated into a bunch of different programming languages. So we're using this one here, inferring out a local image for the Roboflow API. Okay, so we're going to post this base64 encoded image to our model ID. And so remember, in our Roboflow config, that's where we put the L-car model. And so we're constructing that URL. And then we're passing our configuration settings that we want, which is our API key, that we want it to return an image. So this is how it's returning that base64 image with the bounding box. But if I change this to JSON, it would return a array of predictions that I could parse however I wanted. And then we're telling it we want the size of the width of the box around the car to be 5 pixels. And we want it to actually tell us that it's a car. So if I go back here, you can see there's text that says car. If I turn that off, then that would disappear. And if I change the stroke width, this would either get wider or thinner. And then I pass as the body that base64 encoded image, set up the correct header, which is going to be application x www form URL encoded, and then tell it that I want the binary back from the server. So basically, we send that off. The server runs our model on the image and returns back another image with the visualization, which comes back as response.data. We resolve our promise here with response.data, and that ends up coming here. And so that's what we have as image. And then we just respond to the request with that image. And so that's why when we hit /image here, that downloads the current prediction. So that's really all there is to the server side. And then the client side is even simpler. So we've got an index.html file here, which just loads some styling, loads jQuery and a couple of helper functions, and then it loads our main.js file. And then it sets up, over here, we have a status text and a container for our image. Status text, container for image. And then in the main.js file, we can tell it how often we want to update from the server. So I was kind of disappointed with the frame rate that I'm getting back from the Nest camera. It doesn't seem to be coming back that often. But I think there's probably a way to increase that. I just haven't found it yet. Maybe by part 2, I'll have an update there. We're going to update the status text. We'll create an image. And then every time that image finishes loading, we'll hang on for just a second, and then we'll try and load another image. So this load frame, all it does is it's going to set the image source to be that /image route that we created, and then also a cache buster so that it'll actually update every time we do. And then we throttled that so that it only runs with our max frame rate. And this is all of the code. The only other file that we haven't looked at is the CSS file, which just adds a little bit of padding and tells it to be centered on the page. And that's what we have. So to prove to you that this is in fact actually running, so I've got my garage door opener that I'll hit here. It's on a bit of a delay. You might be able to hear my garage door opening, but this should update here in a second, and we should see my garage door opening. And there you can see it starting to move, and you can see the frame rate is actually quite low of what I get back from the camera. So we'll work on that, so I can close my garage door back. And that's essentially all there is to it. So we hacked into our Nest camera. We're pretending to be the iOS app, and we're feeding that stream to Roboflow, which is a model that we custom trained to detect cars. And yeah, that's mission accomplished. So as I mentioned, there's going to be a part 2 of this video, and the reason is that our data set isn't particularly representative of these types of cars from this angle in a garage. So it's doing a pretty good job of detecting my Jeep, but you can tell the other car, it's not even detecting it at all. And so my goal of figuring out when we're using both cars probably wouldn't work very well. I guess in the video earlier, when I backed this Jeep out, it did find this one, so maybe it would. But we're going to improve this model by quite a bit by adding our own custom data and retraining, which we'll do in the next video. So yeah, I hope you enjoyed this. If you have any questions, leave them below in the comments. I'll be watching that. And let me know what you're going to do with your hacked Nest camera. A couple ideas that people have floated so far are keeping track of when the mailman comes each day and letting them know that they can go out and check the mail. Letting them know when their garbage was picked up so that they can go get their trash cans back in. I wanted to create a bus tracker app that lets me know what the bus schedule is and predict when the next bus is going to come by. There's all sorts of different things that you can do. Essentially, anything that your Nest camera is looking at, you can now train a model to detect the state of that. So I hope you enjoyed this video. Don't forget to give it a like below, and excited to see what you built. Have a good one, everyone.